We're going to the moon to explore, and we're going to the moon for scientific discovery.
Our destiny is always to go and see what's further and what's next.
The moon is a stepping stone, and the moon is a place we need to learn how to live so that we can continue to go beyond.
We are focused. We are focused on all that lies before us. Only together will we bring to life this global ambition of returning to the moon. And while our work is far from finished, we've never been closer to seeing a new generation step beyond our home planet. We are building on the achievements of those who came before. The giants who conquered gravity and raised a banner in the heavens, they beckon us to go farther, to the moon and on to Mars, to seek a deeper understanding of our universe and bring all that we learn home. 2020 was a year of unpredictable hardships, and yet, step by step, we resolved to press forward toward this grand vision. The daily efforts of thousands of suppliers from all across this country and around the world fed into stunning milestones and laid the groundwork for history.
Launch team, go.
Artemis has been woven into our culture. It has fostered collaboration across the aisles and across the ponds. It has grown beyond plans and preparations to include hardware and software. And now, it has a heartbeat. You can feel the momentum. It is undeniable. We are going. And together, we will see Artemis light the way.
Our mission to the moon is no longer some far-fetched dream. This is reality. We are going.
This is the next step in evolution.
They're not just PowerPoint slides. They're actually metals being bent, shaped, formed to build the things that we're going to use.
This is real. This is going to happen. We're going.
We are going to the moon to learn how to live on other planets for the benefit of all.
Let's go.
Hello and welcome to the 2022 MicroG NExT Challenge Selection Show. I'm Tranisha Dixon, the MicroG NExT Activity Manager. We're excited to share with you today the undergraduate teams who are advancing to Phase 2 of the MicroG NExT Challenge experience. During Phase 1, undergraduate teams across the country contributed innovative design concepts that may potentially aid astronauts in identifying and collecting lunar samples during spacewalks on the moon, and completing other tasks that may require anchoring to surfaces on the moon. So let's find out a little bit more about these challenges and then also the teams that are advancing to Phase 2.
I am Patrick Petty, one of the activity coordinators with MicroG NExT. This year, MicroG NExT is offering 3 Artemis-focused challenges for undergraduate students, with each of the challenges directly linking to lunar surface operations and allow for students to design mission-enabling hardware for the upcoming Artemis missions. Challenge 1 calls for the design of a lunar sample size location calibration marker, while Challenge 2 requires the design of a lunar sample bag as well as a bag dispensing device. Both of these challenges were designed in partnership with the EVA Tools Office at NASA's Johnson Space Center. For Challenge 3, students designed a lunar reusable surface anchoring device. This challenge is carried out in collaboration with the Small Robotics team from Jet Propulsion Laboratory in California. I'm now going to turn it over to Ronald Beck.
Thank you, Pat. I'm Ronald Ben, one of the activity coordinators with MicroG NExT. For its 2022 iteration, MicroG NExT received proposals from 40 teams consisting of approximately 300 total undergraduate students from institutions across the United States. Thank you to all of the teams that proposed innovative design solutions, and a special congratulations to the teams that are advancing to Phase 2 of the MicroG NExT Challenge. Before we announce those teams, I'm going to introduce Mary Walker with the EVA Tools Group from NASA's Johnson Space Center to provide greater detail on the Lunar Sample Size Location Calibration Marker.
Challenge number 1 is called the EVA Sample Size Location Calibration Marker, or sample marker for short. Artemis astronauts will collect geological samples from the lunar surface during extravehicular activities, or EVAs. All the samples they collect will need to be carefully documented so that the scientists back on Earth can study them. One of the first steps in the sample documentation process is deploying a physical marker next to a potential lunar sample for collection. Astronauts will deploy a sample marker next to a potential sample that they find and photograph or video it to provide the ground team with real-time data for that sample. Using the calibration tools included on the sample markers, the science team on Earth can decide in real time via that video feed or photographs whether they want the astronauts to collect that particular sample. During this time, the astronauts can deploy sample markers at other potential sampling locations for the same kind of review, and they can go back and find the selected samples by the sample marker alphanumeric labels. For this challenge, student teams were asked to design a sample marker for astronauts to deploy on the lunar surface that includes calibration tools like measurement scale, color bar, and grayscale. And each sample marker needs to be less than 1 pound, but also stable when it's placed on the lunar surface, whether flat, inclined, or even on top of a rock or boulder that the astronaut wants to take a sample from. Additionally, the sample markers need to be able to be deployed and retrieved without the astronauts having to kneel all the way down. Sample markers could be used multiple times throughout an EVA or multiple EVAs, so the ease of use for the astronauts wearing the spacesuit is key.
Hi, my name is Adam Nades, and I'm the Deputy Project Manager for Artemis Geology Tools here at NASA's Johnson Space Center. Congratulations to Team LAMP from Embry-Riddle Aeronautical University. ERAU is sending a team to Phase 2 of the MicroG NExT Challenge for the 8th consecutive year. This year, their concept is a lunar sample size, location, calibration marker that will be tested. Welcome back, ERAU, and we cannot wait to see your device tested in NASA's Neutral Buoyancy Lab.
Hi, my name is Heidi Hammerstein, and I'm a spacesuit engineer here at NASA's Johnson Space Center. Congratulations to Team Pillows from California Polytechnic State University, San Luis Obispo. For the 2nd consecutive year, a team from Cal Poly is moving on to Phase 2 of the MicroG NExT Challenge. This year, they will design a lunar sample size, location, calibration marker. Congratulations, and looking forward to working with you in 2022.
Hi, my name is Ryan Noe, and I'm a design engineer here at NASA's Johnson Space Center. Congratulations to the Falcons from Cerritos College. The Falcons will be moving on to Phase 2 of the MicroG NExT Challenge for the 2nd consecutive year. We look forward to seeing their clever design concept, which is a lunar sample size, location, and calibration marker that will be tested here in Houston, Texas at the Neutral Buoyancy Lab.
Hi, my name is Reed Williams, and I'm a Ethos Flight Controller trainee at NASA's Johnson Space Center. Congratulations to the Space Cowboys team Pictor from Oklahoma State University. This team of 2 freshmen, 1 junior, and 1 senior will be moving on to Phase 2 of the MicroG NExT Challenge, and their concept design of a lunar sample size and location calibration marker will be tested in the world's largest indoor pool, NASA's Neutral Buoyancy Lab. Go Pokes!
Are your gnomons getting you down? Are you tired of half-baked sample marker solutions that just aren't working? Introducing Pictor. Pictor is brought to you by some of the greatest engineering minds at Oklahoma State University, with majors in mechanical, electrical, aerospace, and computer engineering. Pictor is a sample marker that meets the first 2022 MicroG Challenge. we used lightweight, flight-like durable materials so that PICTOR clocks in at just under a pound. We've optimized the design of PICTOR to minimize sharp edges and pinch points, meaning you'll never get a scratch while operating PICTOR. PICTOR is designed for easy deployment and recovery, with stowed configuration of 15 by 2 by 4 inches that expands to 20 by 7 by 12. And with a 2x2 alphanumeric label, you'll never lose this sample marker on the moon. PICTOR simplifies the sampling process, allowing for more data to be collected and more effort to be put towards other areas of the mission.
Howdy, my name is Emily Cox and I'm a dive operations specialist here at NASA's Neutral Buoyancy Lab. Congratulations to the suit lab from Embry-Riddle Aeronautical University, located in sunny Daytona Beach, Florida. They will be moving on to phase 2 of the MicroG NExT challenge with their concept design, PRISM, a sample size, location, and calibration marker for lunar samples that will be tested here at one of the world's largest indoor pools, the NASA Neutral Buoyancy Lab. Congratulations to the suit lab, and we can't wait to see you here in Houston.
Hi, my name is Kim Wright, and I'm a flight controller for the International Space Station here at NASA's Johnson Space Center. Congratulations to the red team from the University of Nebraska in Lincoln. One of the teams has been involved since the beginning of MicroG NExT. They are moving on to phase 2 of the challenge for the 8th straight year and will be bringing their concept-defined RIC, a regolith identifying calibration key, which is a lunar sample size location calibration marker, to be tested at NASA's Neutral Buoyancy Lab.
Hi, my name is Andy Klesch, and I'm the lead engineer in the Lunar Trailblazer mission here at NASA's Jet Propulsion Laboratory. Congratulations to the Next Level Devils from Arizona State University from Tempe, Arizona. They'll be moving on to phase 2 of the MicroG NExT challenge, testing their design Wally at the Neutral Buoyancy Lab down at JSC in spring of 2022.
Hi, my name is Goddard Jansen, and I'm a senior engineer working on the International Space Station program here at NASA's Johnson Space Center. Congratulations to the HEC-7 Callisto team, a team of all mechanical engineering seniors from the University of Texas in Tyler. They are moving on to phase 2 of the MicroG NExT challenge for the 3rd time, and this year will design a lunar sample size location calibration marker. Congratulations!
Congratulations to the Lunar Sample Size Location Calibration Marker teams advancing to phase 2. I will now turn it over to Kelly Dries from the EVA Tools Group here at NASA's Johnson Space Center to explain more about the Lunar Sample Bag and Dispensing Device Challenge.
Geological samples collected from the moon during Artemis 3 will need to be stored properly for their transit back to Earth. To do this, astronauts will need sample bags and a dispenser that can dispense bags one at a time. For this challenge, students were tasked with designing a dispenser and a set of bags that are durable enough to handle samples of different shapes and sizes and be easy to use by a suited astronaut.
Hi, my name is Adam Nays, and I'm the Deputy Project Manager for Artemis Geology Tools here at NASA's Johnson Space Center. Congratulations to the Eagle Samplers team from Embry-Riddle Aeronautical University, located on their campus in Daytona Beach, Florida. These Eagles are flying high onto phase 2 of the MicroG NExT challenge and will be designing a lunar sample bag and dispensing device that will be tested at NASA's Neutral Buoyancy Lab in 2022.
Hi, my name is Ryan Nelly, and I'm a design engineer here at NASA's Johnson Space Center. Congratulations to the Illinois Space Society from the University of Illinois at Urbana-Champaign. One of the teams that has been involved since the beginning of MicroG NExT. They will be moving on to phase 2 of the challenge for the 8th straight year and will design a lunar sample bag and dispensing device. Way to go, team.
Hi, my name's Mary Walker. I'm a project manager for the EVA Tools Group here at NASA's Johnson Space Center. Congratulations to the red team from the University of Nebraska in Lincoln. They are moving on to phase 2 of the challenge for the 8th straight year with their concept design Thanos, which is a lunar sample bag and dispensing device. We can't wait to get Thanos in the water here at the NBL to be tested.
This is Thanos, our tool for handling aggregate and novel specimens. This design uses nested polypropylene bags, each with an attached sealing bar that folds embedded ductile wires within the bag seams to create a labyrinth seal. The design you can see here was based on minimizing the system's usage fatigue while maximizing smooth fluidity and reliability when in motion. Sample acquisition is a current linchpin of space exploration and will continue to be so in the future. Our team's design intent is to provide a versatile, simplistic instrument that works as a dependable aid to astronauts. Our aim is to produce a final product that can be implemented on manned missions to any extraterrestrial topography.
I want to say great work by all of the Lunar sample bag and dispensing device teams selected to advance on to Phase 2. I will now introduce Andy Klesch from NASA's Jet Propulsion Laboratory, who's with the JPL Robotics team. He will give us more details about the Lunar Reusable Surface Anchoring Device.
Hi. This year, students are going to be taking on a brand new challenge through the MicroG NExT program at NASA's Jet Propulsion Laboratory. As we prepare for Artemis and a return to the moon, students will be building an anchoring device, allowing an astronaut to deploy it with one or two hands, unpowered, and to grasp and provide a force of greater than 10 pounds. Now, this anchoring device will be used for robots to collect samples, for astronauts to pick up rocks, or to provide a tethering point for larger assemblies and vehicles. We look forward to seeing what the students will come up with as they have proposed ideas from across the nation, and next spring we'll be testing them out at NASA Johnson's Neutral Buoyancy Lab.
Hi, my name is Justin Koch, and I'm a robotics engineer here at NASA's Jet Propulsion Laboratory. Congratulations to the Ank Roarers team from Columbia University. These Lions, made up of the class of 2022, 23, 24, and 25, are roaring into Phase 2 for the 7th year and will design a lunar reusable surface anchoring device to be tested at NASA's Neutral Buoyancy Lab.
Hi, my name is Tyler Duncan, and I'm currently at the Space Vehicle Mock Facility here at NASA's Johnson Space Center. Congratulations to the Cyrox team from Iowa State University. These Cyclones of Iowa State are moving on to Phase 2 to have their concept design of a lunar reusable surface anchoring device tested in Houston at NASA's Neutral Buoyancy Lab.
Hi, my name is Kim Wright, and I'm a flight controller for the International Space Station here at NASA's Johnson Space Center. Congratulations to the Helios team from the University of Texas, Dallas, participating in MicroG NExT for the first time since 2016. And they are moving on to Phase 2 and will design a lunar reusable surfacing anchoring device.
Hi, my name is Justin Koch, and I'm a robotics engineer here at NASA's Jet Propulsion Laboratory. Congratulations to Team Astra for Virginia Polytechnic and State University. This is the 5th year that a team from Virginia Tech is moving on to Phase 2 of the MicroG NExT Challenge, and this year they will design a lunar reusable surface anchoring device. Awesome job, can't wait to see your device in the water at NASA's Neutral Buoyancy Lab.
We're Team Astra from Virginia Tech. We're developing SWAT, or spacewalk anchoring tech, to physically support astronauts on the lunar surface. Our anchoring device will be contained within a 6-inch diameter and 18-inch height tube. Inside the anchoring device is a 12-leg system. Each leg will encase 10 plastic frames, each with 3 microspines. The SWAT anchoring device uses these microspines to grip onto a variety of surfaces without penetrating the surface. To use the device, astronauts push down on the handle to extend the 12-leg system out of the container. The astronaut is then able to place the microspines on the surface and tighten the grip by pulling the handle back up. The microspines will have at least 10 pounds of holding force. To release the microspines, the astronaut will push the handle back down through a ratchet and pawl mechanism. To restore the mechanism, the astronaut simply pulls the handle back to the uppermost position. Astronauts will benefit from the SWAT on future lunar missions from its intuitive and robust design, which in turn contributes to a prospective future in space exploration.
Hi, my name's Mary Walker. I'm a project manager in the EVA Tools group here at NASA's Johnson Space Center. Congratulations to the Space Wranglers from the University of Wyoming. In their first year of participation, the Space Wranglers become the first team from the state of Wyoming to advance to Phase 2 of the MicroG NExT Challenge. The team will be designing a lunar reusable surface anchoring device. Great job, team.
Hi, my name is Kim Wright, and I'm a flight controller for the International Space Station here at NASA's Johnson Space Center. Congratulations to the Rose Rocks from the University of Tulsa. This is the first time a team from the University of Tulsa is moving on to Phase 2 of MicroG NExT Challenge. to have their concept design Brad, the basic rock anchoring device, tested at NASA's Neutral Buoyancy Lab.
Hi, my name is Annie Klesch, and I'm the lead engineer in the Lunar Trailblazer mission here at NASA's Jet Propulsion Laboratory. I'd like to congratulate Boise State University and their microgravity undergraduate design team. The Broncos are moving on to the next phase of the MicroG NExT Challenge for the 7th year in a row.
Hi, my name is Reed Williams, and I'm an Ethos Flight Controller trainee at NASA's Johnson Space Center. Congratulations to the Space Cowboys from Oklahoma State University with their concept design Libra. Libra, otherwise known as the Space Lasso, a lunar reusable surface anchoring device, will be tested in spring of 2022 at NASA's Neutral Buoyancy Lab. Go Pokes!
Congratulations to the Advancing Lunar Reusable Surface Anchoring Device teams. MicroG NExT is one of several Artemis Student challenges. The following video provides more information on some of the unique opportunities for the Artemis generation to get involved with NASA.
NASA's Artemis mission will land the first woman and the first person of color on the moon.
And today's students are the Artemis generation.
If you're a student, you can design and build technologies that support the Artemis mission with NASA's Artemis Student Challenges.
No matter your background or experience,
you're invited to choose a challenge that interests you, whether it's
rockets,
robots,
tools,
software,
vehicles,
or other technologies. There's an exciting challenge for you.
So find a mentor and build a team of students.
Review the rules and requirements.
And bring
your ideas
to life with NASA's Artemis Student Challenges.
Visit stem.nasa.gov/Artemis and see how you can join one of NASA's mission-related student challenges.
As you can see, there are several exciting ways to get involved with NASA. Thank you to all of the viewers, and again, congratulations to all of the teams advancing to Phase 2 of the MicroG NExT Challenge as we look forward to testing your devices in 2022.